The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so I'm going to work through problem number 8 for Physics 2020 Midterm Exam 1. And problem number 8 states, Mia Hamm kicked a soccer ball that traveled 30 meters. If the ball initially left the ground with a speed of 20 meters per second, what was the angle between the initial velocity vector and the horizontal ground? Alright, so to help us solve this problem, I drew a little diagram that represents the problem statement. And so basically, we're dealing with a ball that's basically kicked with an initial velocity. And so this is going to be projectile motion for the simple fact that once the ball is initially kicked, there's nothing else acting on the object, which is the ball, except for gravity. And so this is the definition of projectile motion. And we know that the ball, once it was kicked, it traveled actually a distance of 30 meters. And the problem is asking us to basically determine the angle between the velocity vector and the ground and the horizontal ground when this ball was initially kicked. All right, and so I encourage you to use your formula review sheet for Physics 2010 for this first midterm exam 1, and I'm going to be referring to this review sheet. So if you look in the section for projectile motion, which is on the second page, you will see various equations and formulas for the projectile motion in the x and y direction. And if you look at the bottom of that section, you will see a formula for range. And given the information in the problem, we have an initial velocity, and we have a range that's given, which is 30 meters, and we know that gravity is 9.8 meters per second. And so using this particular formula for the range, we have the range is equal to the initial velocity squared times the sine of 2 theta divided by the speed of gravity, acceleration due to gravity. And so this is the formula that we'll be using from the formula sheet. One thing to note is that we can use this particular formula on the formula sheet because we know that the initial position that the ball is being kicked is at a height of 0, so basically it's on the ground. If your initial height does not equal 0, then you would not be able to use this particular formula for a range. There's a different formula. And so we are able to use this formula for the range, given the fact that where we're kicking the projectile is from a height of 0. All right, so now, since we want to, we basically just need to solve this equation for theta in order to solve the problem. And so whenever we manipulate, we can algebraically manipulate this equation so that we get basically 2 theta is equal to the sine inverse of g multiplied by r divided by v sub 0 squared. All right, so all I did was I just solved this equation for 2 theta, okay? And such that theta is going to equal to the same thing. But this whole thing now is divided by 2. Okay, and so now we can just substitute in the information. So we have the sine inverse of we have the sine inverse of 9.8 meters per second squared times the range, which is 30 meters, divided by made a mistake here. Divided by the velocity, which is 20 meters per second, this quantity squared. And this whole thing is divided by 2. So that when we look at our units, we should be dimensionless on our units because theta is going to have units of degrees. And so we'll have a meter squared on the bottom. That cancels out with these 2 meters, which gives us a meter squared. We have a second squared on the bottom, which cancels out with this second squared. So indeed, we are dimensionless. And when we plug in the numbers, we get theta to equal to 23.65 degrees. And that is the answer.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.